Hi, good morning, class. This is the week four Zoom session here, the instructor session, and we are moving right along in the second half of the course. Um, this week's material, well, let me actually go over here. Let me go to the course. Here it is. Just bear with me, sorry. So we're over here at the course, and oh, got a little error here. But what we're working on a lot. Let me do this. Sorry, modules. Let me go down to modules. We were in week four. There we go. And you'll see here the three main topics that we're covering here this week is all about fractions and decimals. Uh, Working with fractions and decimals, converting them from fractions to decimals, decimals to fractions, and then doing the operations add, subtract, multiply, divide, as well as also working with mixed fractions. So, I think a lot of this is going to be review for you. Fractions is not, everybody's, cup of tea. It's not your favorite thing. And, candidly, I hate fractions. I never work with them. I avoid them at all cost. But it is important to know because we do use the concepts in other fashions that we'll see later on in this course as well. But it is good to know. I mean, you use fractions in the real world too, but um, anyway, so let me one thing I wanted to mention here, and I saw it on the other page, so that's why I went there first. Uh, I've got a series of videos here all about fractions. Goes over, and they're all from Khan Academy. So if you just click on one of them, let's see, finding common denominators. If you ever have a question about that, going to straight take you to YouTube to Khan Academy, a ton of videos there, and they're not too terribly long. And Khan Academy is wonderful. So I do encourage you to use those resources if you have any questions. But again, I'm really confident that you know this stuff cold already. If before walking into the class, so I'm real confident you're going to do well. So, anyways, but with that in mind, I'm going to also kind of select some topics here from our PowerPoint presentation so that it kind of make the most effective use of your time. And let me go, it's right here. Okay, so it's all about fractions and mixed numbers here. So what we want to do is take a look at, a couple of things. One is what is the least common multiple? And that's important for doing adding and subtracting of fractions. And so let's talk about that first. As the least common multiple is the smallest number that is a multiple of a given number. I don't really like that formulation and the way it's stated. So the way that I say it is it's the first number that two other numbers will go into. First number that the other two will go into. So if we take a look at something like 15 and 12, we ask ourselves, what's the first number that both 15 and 12 go into? And when you're talking about the least common multiple, you're typically looking for something that's larger than 15 and 12. It's not going to be smaller than, always going to be probably 99% of the time larger than that. So what's a higher number that both 15 and 12 go into? Okay. So there's a myriad of ways you can do it. One way you can do it is, let's list out the factors of 15, 15, 30, 45, 60. And what you do is you just stop when you see the first number that 12 goes into. Okay, well, there's a number that 12 goes into is 60. How do I know? Because it's 5 times 12 will give you 60. But 12 won't go in the other ones of 15, 30, or 45. So that's a way that you can do it. That's a pretty quick and direct way to do it, is just to start listing out multiples of one of the values and stop once you get to a value that the other number goes into. I find that to be the quickest way, and that's the one I'm going to advocate here and kind of just go with. There is another method that is utilized in the materials. I'm going to leave it to your work in Alex to go over that, but I think you're going to find this pretty effective. So we could do the same thing over here for what's the least common multiple between these three values, 8, 15, I'm sorry, 10, 15, and 8. And just list values of, the first one, okay, let's see, you can do, 10, 20, 30. Okay, 15 goes into 30, but 8 doesn't go into 30. So we got to keep going. Okay, so then 40, 50, 48 goes into 40, 8 goes into 40, but the 15 does not. So we have to keep going. So then 60, So we kind of keep just go 60, 70, 80, oops, 90, 100. But so it's going to be a lot, 110. So sometimes it is fairly extensive. And so let me kind of sort of get the answer here. Oh, is it 80? No, it's not 80. So sometimes you just have to keep building your list, go higher, higher, and higher. And so maybe sometimes you use the higher one. So let's work on 15 instead. Okay. See, sometimes you just have to do a trial and error. So 15, 30, 45, um, 60, just find something that 8 goes into. 75. Once we find something that 8 goes into, we're really probably in good shape. Then 90, does 8 go into 90? No. Let's see, 8 goes into 90. Nope, doesn't. So keep going. 105. No. 120. Oh, 120. Let's check 120. That's a good candidate. Yes. 8 goes into 120 right there. 8 goes into it, and certainly 10 goes into it too. So 120 is the value that all three go into. So just build your list of multiples and you can kind of quickly get your least common multiple. That's the way that I advocate doing it. There is a whole nother process here, but I'm not going to go over it at this juncture. Um, we want to talk about the notion of equivalent fractions. And basically, all equivalent fractions means is that you're taking a fraction and rewriting it with a different denominator, but an equivalent, but with a still it's the same fraction. So, for example, the value of 2/9, how do we write fraction 2/9 with a new denominator of 36? And so you ask yourself, well, what value did you have to multiply the 9 by? What value did you multiply the 9 by to get to 36? And the answer is 4. So the rule is that you have to multiply the top and the bottom by the same value of 4. So we have to multiply that 2 in the top also by 4, giving us a value of 8. So we say that these two fractions here, 2/9 and 8/36, are equivalent with each other. In other words, they're the same proportion, the same ratio. If we were to convert it to a decimal, they would each give us the same decimal, if you will. So all you do is you look at what value do you have to multiply one of them by, and then you do it to the top and bottom. So let's do something like this. 2/3 to how do we translate the fraction of 2/3 with the denominator 15? Same concept. What do you have to multiply the 3 by in order to get 15? Well, that value is 5. So we're going to multiply the top by 5 as well and get the value of 10. And one more thing to notice, let me see. We can also, all these examples here are talking about values in the denominator, but we could do something like this. Suppose we had, 5/6, and we want to write it as a fraction with 20 in the numerator. It's the same idea. What did you have to multiply the 5 by in the numerator to get 20? Well, it's multiplying by 4, so you have to do the same thing to top and bottom, and that gives us the value of 24. So it works whether you're trying to find the top or the bottom is what I'm trying to say. Okay, but this whole idea here of trying to find equivalent fractions, and you probably know this, you can see the writing on the wall, you're trying to get common denominators in your fractions. That's the whole purpose. Change the fractions so that you have common denominators. Okay, so then with that in mind, you're ready now, adding and subtracting fractions. I mean, that once you know how to find the common denominator, and then you know how to change a fraction to a common denominator, then you can add and subtract fractions. Why? Why do we need to be able to do this? Is because the rule is that you can well, here's the rule. It's not so very clearly stated, but basically you need to have the same denominator in order to be able to add and subtract fractions. You can only add and subtract fractions if they have the same denominator. So let's take something like this. You have to ask yourself, we have 1/4 plus 5/4 here. Do they have common denominators? Do they have the same denominator? Yes. So what you do is you collapse them down into one fraction with the same common denominator, and then you just add the values. So because it's addition up here, you add the 1 and the 5 in the numerator, and that's going to give you the fraction 6/4. And the 6/4, sometimes we can stop, sometimes we have to go a little forward. You have to ask yourself, hey, can this thing simplify? And yes, this can simplify. You're looking to see if there's anything, a common factor that you can factor out. So yes, we can cancel a 2 from top and bottom by dividing by 2, and that gives us the final answer of 3/2. Now notice we can also add and subtract 3 fractions at a time. That's okay. They all have the same denominator, 15. So you collapse it into one fraction, you add the 2 and the 1, and then subtract off 13. And now do that addition, subtraction in the numerator. 2 plus 1 is 3, minus 13 gives us then -10. So this becomes -10/15. And then again, you would want to simplify the fraction. So we're going to cancel a 5 from top and bottom. So it's going to be -2/3. Okay. So now what we want to see though is what? Forward here. Go forward. Unlike denominators. That's what we want to do. So here we have denominators that are not the same. So what we want to do is we want to find the common denominator for both. Now, you can use the LCM, the least common multiple. There is nothing wrong with that. And we can see the least common multiple here. What's the first value that both 6 and 4 will go into? Well, that value is 12. That value is 12. So we want to change each of the fractions to an equivalent fraction with 12 as the denominator. So that's where you go through the process. What do you multiply 6 by to get 12? You multiply by 2. So you have to multiply the top and bottom by 2. And here, the second well, let me put this over here, sorry. So 2 times 1 here gives us 2/12, okay? And then for this other fraction, 3/4, multiplying top and bottom, what do we multiply by? Well, we multiply top and bottom by 3 to get the 12. So we have to multiply top and bottom by 3. So that 3 times 3 right there becomes 9. Now that we have common denominators, we add the 2 and the 9 right here in the numerators to give us 11/12. Okay, sorry about that. That was my wife calling. I apologize. Okay, so let's see some more examples just to kind of drive home the point here. Okay, so here's another one. 1/10 plus 1/15. Sometimes it's easy to see the LCM, sometimes it's not. It kind of all depends. So here, what's the first number that both 10 and 15 go into? That value is going to be 30, okay? That value is going to be 30. So what do you have to multiply the 10 by to get to a denominator of 30? It's 3, so you have to multiply top and bottom by that 3. So that gives us 3/30. And what do you multiply the 15 by over here to get the denominator of 30? That's 2. So we multiply the 2 and the 1 here by 2. And then add. So we add the 3 and the 2 to get 5 in the numerator over 30. And just always keep in mind, if you can simplify your fraction, please do so. So you get the final answer of 1/6. And it works for subtraction too. So I'm not going to go over the process for subtraction, but it is the same thing, even if you have subtraction. I'll do one. I'll do one. I apologize. So what do we have to do? What's the least common denominator? Well, notice what's the first value that 5 and 15 go into? The first value is actually 15. So we don't have to change this second fraction at all. We can leave it as 7/15. So the second one, though, is the one we have to multiply by. And so that is what? We have to multiply top and bottom by 3. Pardon my handwriting, we get a little jammed up here. So that becomes 27/15. Now we do the subtraction. 27 minus 7 in the top is 20, and then over 15 in the denominator. And simplify. We're going to cancel a 5 from top and bottom. So canceling a 5 from the 20 leaves a 4, and canceling the 5 from 15 gives us a 3. And that is the answer. Okay, I'm sure by this point now, everything's starting to become like a refresher for you. So I'm going to jump ahead a little bit. And let's see. One thing to take note of here, let's look at something like this. Let's see. It says, write the answer as a fraction. And notice this one right here. Sorry. Notice this number right here is not a fraction. So how are we going to, how do we use our concepts of adding fractions when you have just a plain number like -5? Well, the idea is that you can write every number as a fraction by taking that number and placing it over the value of 1. So this really is treated as -5 over 1 plus 3/4. And so now the common denominator is going to be 4. So multiply the top and bottom of that first fraction by 4 to get -20 over 4, and then add the 3/4. And then do your addition. -20 plus +3 is -17 over 4. So that's the idea, is anytime when you have a regular integer or whole number, you can just write it as a fraction by placing it over the value of 1. Okay. So let me jump down here. I'm going to move ahead. Oh, where are we at? Multiplying. Yeah, multiplication, division. And really, multiplication and division are actually the same thing. There's only just one slight difference between the two. So here's sort of the process, if you will. What are we talking about? Mixed? Was this mixed already? Huh. Hold on. Okay, so they kind of jumped ahead in the PowerPoint presentation. That's okay. Uh, we can go ahead and do it. We'll do it here. But it kind of jumped ahead and skipped over the process of multiplying. So what we're going to do here is we're going to show you two things. One is, how do you deal with mixed numbers? And then how do you do multiplication and division with mixed numbers? And it kind of goes hand in hand too. So when we mean mixed, by the way, we mean where you have a whole number and a fraction component. 7.5, 7 1/2, or 4 2/3. Those are mixed fractions because they have a whole number and a fraction component. This is so when you have something like this, and my general recommendation when working with mixed numbers is don't work with a mixed number. Convert them to a fraction. Convert them to a fraction. And how do we do that? Well, the way that you convert a mixed fraction to a regular fraction is you take the denominator here and you multiply it with the whole number. Okay. And then you add the numerator. Okay. So take the denominator, 2, multiply it to the 7, and add it to the 1. And you're going to place all that over the original denominator here of 2. Okay. And so do the calculations in the top, order of operations. 2 times 7 plus 1, 2 times 7 is 14, and then plus 1 is 15 over 2. Do the same thing here. 4 2/3, well, we take the 4 times 3. So 4 times 3, and then add the 2 in the numerator. So, and place that over 3. So then so now you simplify. 4 times 3 is 12, plus 2 is 14. And that's placed over the denominator of 3. Now you can, I'm sorry, I'm doing plus. It's not supposed to be plus. It's what? Times. But notice, I'm going to make a little side note here, is the process for adding, subtracting mixed numbers. I recommend going ahead and converting it to fractions, improper fractions, and then just apply your process for adding, subtracting, getting common denominators. I find that to be the most direct and easy way to work with mixed numbers as well. So here we're looking at multiplying numbers and dividing. So what do we do? And from this stage forward, now you're just applying the rule to multiply fractions. And what is that rule? Well, basically, it just says this. You basically multiply straight across, okay? Multiply straight across. So we're going to multiply the 15 and the 14. So that becomes 15 times 14. And we're going to multiply the 2 and the 3. Now do the multiplication. So 15 times 14 is what, 210? Check my math. I'm going to check my math. Make sure that you're doing a calculator too. Yeah, 210. And then over 6. And now, uh, we simplify. 210 divided by 6. We can cancel. Oh, well, fortunately, that just cancels down to 35. So that's the answer right here. Okay, so a quick recap of the process is when you're dealing with mixed fractions, it doesn't matter if you're adding, subtracting, multiplying, dividing. I recommend you turn it into an improper fraction because it's easy. I find it's easier to work with. Okay. So once you convert to improper fractions, then you apply your rules for adding, subtracting, multiplying, dividing, whatever you have. And here, because we have multiplication, that's what that big dot's supposed to mean. You just multiply and divide, you multiply straight across, multiply the values. And so that's how we got the 210 over 6. And then we simplified our fraction, and that's how we got the 35. Okay. Okay, so how would we do something like this? Well, treat the 12 as 12 over 1. Well, we don't have to do that for this, actually. Well, yeah, we ultimately will. Sorry. So convert this one and 7/9 to an improper fraction. So this becomes negative 12 over 1. Treat that as a fraction times the mixed fraction 1 over 7, 1 and 7/9 becomes 9 times 1 is 9 plus 7 is 16 over 9. Now do the multiplication. And for that, excuse me, remember you're multiplying straight across. So negative 12 times 16 is negative 192. And then 1 times 9 is 9. Now we look to see if we can cancel anything. And fortunately, we can. What we can cancel is a 3 from top and bottom. Canceling a 3 from top and bottom. So when you cancel a 3 from top and bottom, we get negative 64 in the numerator over 3. And there you go. That's the answer. Okay, so we've covered a lot of ground actually in these problems right here, converting from mixed fractions to an improper fraction, and then multiplying fractions themselves. So now the process is to see, well, how does the process change if we have a division? Okay, so notice here we still have mixed fractions. So first things first is you want to convert each mixed fraction to an improper fraction. So 7/2 becomes 15 over 2. Remember, it's 7 times 2, then plus the 1. And then divided by 3 times 4 is 12, plus the 2 is 14 over 3. Okay. Now we have a division symbol here. So how do we do with that division? Well, the division symbol says change the second fraction, always and only the second fraction. What you do is you flip it around. You flip it around, okay? So the 15 over 2 remains the same, but this one here, you flip it. So it flips to 3 over 14, and then you change the division symbol here to multiplication. And now you do the multiplication straight across. And so that gives us what? 15 times 3 becomes 45 in the numerator, and then 2 times 14 becomes 28 in the denominator. And that's actually it. We can't simplify that any further, unfortunately. Okay, so recap of the process. Here we have mixed fractions. So first you convert them to improper fractions. Then you deal with the division. How do you do that? You flip the second fraction over. So from 14/3 to 3/4, flip it upside down and change that division to multiplication, and then apply your process for multiplying fractions, multiplying straight across. And that's it. And I think that's pretty much it here with fractions. We've done, I think, virtually everything. The only thing, let's see, let me jump ahead here. Subtraction, we've done that already. Negative numbers, that's just incorporating your rules of signs. I'm not going to go up, I'm going to advance over that. Let's see. Decimals. The only thing, The only thing I'm gonna skip ahead on rounding because I think you know that already just from your life experience. But the only thing I want to jump ahead here too. Let me find it. Uh, is well let me go back. Maybe it's not in here. Maybe y'all aren't doing it this week. Bear with me. Okay, well I'll go back here. Adding, subtracting, multiplying, dividing decimals. You got a calculator. I encourage you to use it. I'm not going to go over those rules because you already know how to do that. But what I am going to go over briefly here is conversion. And what I was trying to look for is basically you're going to be asked to do two things. How do you convert a fraction to a decimal? And then how do you convert a decimal to a fraction? Okay. So let me do the first one. How do you convert a fraction to a decimal? And that really is just division. So let's take, a fraction here, 3/4. The way that you uh, the way that you convert it to a decimal is you have to just recognize that the fraction bar in the middle means division. So this fraction here, 3/4, can be thought of as 3 divided by 4. And so you go to your calculator, type in 3 divided by 4, and you get 0.75. It's just as quick as that. So suppose we had something like this, 27 over 6. Well, that's treated as 27 divided by 6. And so go to your calculator, 27 divided by 6 gives us 4.5. That's it. That's it. Suppose you had a mixed fraction. Let's take, uh, 3 and, 1/2. Okay. Well, what you have to recognize here is that when we see 3 and 1/2 here, we're actually treating this as, and how do you say it, by the way? Talk to yourself. 3 and 1/2, 3 and 1/2. Well, the word and, when you say it, 3 and 1/2, the word and actually means addition. So this actually means 3 plus 1/2. Convert the 1/2 to a decimal of 0.5. And so you get the decimal of 3.5. So the key is that addition sign buried in between there. That's how you do it. Okay, so then we have the final thing we're going to do is then this. Suppose you have a decimal, how do you write it as a fraction? And that's all based upon the places. Let me do this. So here, what you have to recall is, remember, each decimal spot has its own place. Okay, so the first decimal spot is called the tenths place. The second decimal spot is called the hundredths place. And the third decimal spot is called the thousandths place. So let's take something like this, 0.847. What you do is you look at the place of the last decimal, and that's the 7 here, and it's in the thousandths place. So what you do is you take the 847, no decimal, put it in a fraction, the numerator of a fraction, and the place here that you're at, the thousandths, write the number, 1,000. It's the last decimal place that tells you what number you're going to write down here in the denominator. So that's this decimal as a fraction, 847 over 1,000. Okay, so let's come over here to 4.16. The decimal here means the word and. Remember when you're writing a checkbook, a check, $4.16. Well, what does that mean? 4 and 0.16. Okay. So 4 plus, so how do we do this? 0.16. Well, we're going to take the value 16 without the decimal, put it in a fraction, and the last place here is in the hundredths place. So put 100. Okay. So this can be then the 4 and 16 means that this is a mixed fraction, 4 and 16 over 100. And what you want to do is just simplify the fraction 16 over 100. And that's what? 4 over 25, cancel a 4 from top and bottom. So this becomes the mixed fraction 4 and 4/25. You could also write it as an improper fraction too, if you want, but you don't have to, unless the directions tell you to. So that's the idea. It's really just as direct as that. You take the number here without the decimal, put it in a fraction, numerator of fraction, and the denominator is going to be the final place, the place where that final decimal value is. And so here, that's the thousands place. Okay. Here, same thing here. Let's do this one. So this is negative. So we're going to put negative and take the 25 without the decimal. Now put it in a fraction. So what's the place here for 5? Well, 10th, thousandth, I'm sorry, I messed it up. 10th, 100th, 1000th, 10,000th is the fourth one. So put that in a denominator with 10,000. And then you simplify as best you can. 25 does go into 10,000. We can cancel it 400 times. So this is the same thing as the fraction -1 over 400 when you simplify it. That's what that one is. Same process though. Take the value without the decimal, put it in the numerator, and then the denominator is going to correspond to the place of the last term, the 10,000th place. And that's it. Okay, so I hope you found this helpful. Let me know if you have any questions as you work through decimals and fractions this week. Like I said, I'm extremely confident you know this already without my instruction or going through even Alex. But there could be some rust on the wheels, and so if you need some assistance knocking off that rust, let me know. Glad to lend a hand. Hope you have a good day. Bye bye.